Right, suppose you're given this half sphere of radius A. Radius A. And the goal is to find the centroid of that. So let's put it in a coordinate. Okay. And then the formula for, I guess we don't need the formula yet. The formula for the centroid is like z bar equals to 1 over the volume, integrate, you need triple integrate. What do I integrate? For z dv, that's what you need. And I explained that this is really just taking the average value of the z coordinates over the entire volume. That's how you should think about this. Now, I wrote only the z bar because I know what x bar and y bar are. What are those? Zero. X bar and y bar are 0. Why?
The center.
The center of mass is somewhere here along the z-axis, right? Yeah. If it's along the z-axis, the x and y coordinates of the centroid will be 0. That's why we only need to calculate the z bar. Yes?
In what case would you have to find more than like just z?
Sometimes I might give you that. I don't know. Yeah. But a lot of times you would get a question where some of the others are symmetric, so you don't have to calculate that. Yes?
So say if that was rotated like 90 degrees and it was along the z-axis.
Right, right. If it was like that, then you would only calculate the y coordinate. Okay. If it was like over here, then you would only calculate the x coordinate and use the symmetry to figure out the other one. Yes?
So instead of doing that, could you just do like 4a over 3 pi for z? Because it's a half sphere in the z direction.
Half sphere on the z direction. So what do I do?
Like instead of doing the triple integral, can you just look at it as like half a circle in the z direction? Is it symmetrical?
So if you compare this with the case when we have the disk, so all right, so for the disk of radius A, we figured out that it was 4 pi over 4a over 3 pi, right? 4a over 3 pi. That's what we got for the center of mass. Now, if you compare that with this, would the center of mass of this will be lower than that point or higher than that point or exactly the same? What do you think?
I feel like it would be the same.
Actually, I think my intuition says it should be lower than this value. It has to be lower than this value. Why? Because if it's three-dimensional, you have more stuff down here than compared to this. Yeah, if you rotate this around and think about the masses, you have more things closer to the xy plane than up there. Okay. So I think the center mass of this thing should be a value that's smaller than this value.
Okay.
So let's actually do that. After the computation, we'll try to compare that with this. Any other questions? All right, good. So let's actually do the computation. All right, for the volume, we calculated the volume of the sphere. Do you remember the volume of the sphere? 4/3 pi r cubed, right? Now this is half a sphere, so what should we use?
2/3.
Half of it, right? So it's 2/3. And what's the radius? A. So that's the volume that we're going to use for V. So it'll be 1 over 2 over 3 pi a cubed. Now we have to handle this one. Now what kind of coordinate is the best for calculating this? What do you think? Okay, well, it's a multiple choice. Rectangular, cylindrical, spherical. Which one? Spherical, of course. It's a sphere, so spherical coordinate is the best. Okay? So we're going to use spherical coordinates. That means dv is what? In spherical coordinates, dv is rho squared sine phi d rho d theta d phi. What about z? What is z equal to?
Z.
Yeah. In spherical coordinate system, z is equal to rho
Rho cosine.
cosine phi. That's the formula, okay? If you forgot, z equal to rho cosine phi, r equals to rho sine phi, and therefore x is rho sine phi times cosine theta, y is rho sine phi times sine theta. Okay? So you'll have that somewhere in your notes. Okay? All right, so we have this. Now, let's do the integral. Oh, and then we have to figure out the bounds. Okay. For the rho, if you try to integrate this in terms of the spherical coordinate system, rho is an increment from the origin, right? So if you think about yourself shooting lasers from the center, okay? So when these rays are coming out from the center, when does it begin to overlap this region? And when does it end? Where does it begin? Where does it end?
0 to A.
0 to A, right? Always, right? As long as it has some overlap, it always is from 0 to A. Okay, what about theta? Theta is this angle, right? Yeah. 0 to 2 pi. It goes all the way around, right? It's 360 degrees for the theta. Now, what's phi again? Phi is the angle from the North Pole, the z-axis, right? So, if you're at the North Pole, what's the value of phi?
Pi over 2.
0. The angle from the North Pole is 0 if you're at the North Pole. And then it goes down. Where does it go down?
South.
90, so
Until the equator, right? And the equator is 90 degrees from the North Pole, right? So that's pi over 2.
No.
So phi starts from where?
0.
0 and goes down until
Pi over
pi over 2. Okay? So that's what you need. Now, what if we weren't doing the half circle? What if we had the full circle? What would phi be? Starting from 0 to pi. The South Pole will be pi. North Pole 0, pi over 2 equator. Pi will be the South Pole. Okay. Actually, that's very different from the longitude and latitude, because in the longitude latitude system, the latitude 0 is the equator. Now, in this system, phi equal to pi over 2 is the equator. Okay. All right. So you have d phi from 0 to pi over 2. And then we compute this, and we're going to get the answer. Okay? Let's continue. Right. You multiply 3 top and bottom to get rid of this annoying 3, and you get 3 over 2 pi a cubed. And then 0 to pi over 2. And then 0 to 2 pi. Now, we first have to integrate by rho. How do you integrate this? Rho times rho squared is rho cubed. If you integrate rho cubed, you get 1/4 of rho to the 4th. And you still have cosine phi and times sine phi. And then you plug in a and 0, d theta, d phi, a and 0. And then when a goes into rho to the 4th, you get a to the 4th, right? So you get 0 to pi over 2, 0 to 2 pi. When a goes into rho, you get 1/4 of a to the 4th cosine phi, sine phi, d theta, d phi. Now, although this looks horrible, if you integrate by theta, what would you get?
1.
Yeah, it's just integrating 1 by theta. There's no theta here, so the entire thing is considered as a constant. When you integrate a constant, you just put, no, if you differentiate a constant, you get 0. If you integrate the constant, you get just theta attached. That's all you get if you integrate that. Okay, so it's 3 over 2 pi a cubed, 0 to pi over 2. If I integrate this, I'm going to get 1/4 a to the 4th cosine phi, sine phi, times theta, and into theta I have to plug in 2 pi and 0. Alright, it's 3 over 2 pi a cubed. And then when I plug in 2 pi to theta, that's 2 pi. When I plug in 0 to theta, that's 0. So I end up with 1/4 h to the 4th times 2 pi from the theta, and you still have cosine phi sine phi d phi. Okay, I see something good here. I see that there's a 2 pi and 2 pi which cancels. That's nice. And also this is a constant, so let's bring them outside. So I get equals to 3 over a cubed times 1/4 a to the 4th. Oh, this can be reduced too. Okay? And then I have to integrate from 0 to pi over 2 of cosine phi times sine phi d theta. Not d theta, sorry, d phi. All right. Here, this is an easy integral because it has the structure of a function multiplied by its derivative. And although I told you about this shortcut, maybe you forgot it, so let me say this again. If you have a function times its derivative, and if you integrate it, what do you get? You get 1/2 of the function squared plus c. That's a handy formula. It appears many times enough so that you should memorize it, okay? So in our case, sine, if you take that as f, this derivative is cosine, right? Therefore, the integration is square of this times 1/2, right? So that's what we get. We're going to get 3 over a cubed times 1/4 a to the 4th times 1/2 sine squared of phi, and you're plugging in pi over 2 and 0. What do you get if you plug in pi over 2 to sine? What's sine of pi over 2? 1. It's positive 1, and if you plug in 0, you get 0. So you get 1 minus 0, so that's just 1 if you plug this in. So you end up with just 1/2, right? And it's almost done, because now, if I reduce a cubed with a to the 4th, you just have 1a surviving. This will be 1 if you calculate. So you end up with 3 on top, so 3a, 4 times 2 on the bottom, so that's it. That's the formula for the center of mass. Now, I said we're going to compare with this disk, right? If you think about the disk, this is 4a over 3 pi. And if you convert this into decimals, it's about 0.44a. And this one, if you convert it to decimals, this is 0.375a. So what do you think? This is lower than this one, right? So it does confirm our intuition that the sphere should have a lower center of mass.